Hey everyone, we're about to get started. Just want to check if the sound's good, video's good, and everyone's feeling good. I'll be waiting for some confirmation in the chat. Let's post this on Slack. Share the link. I want to make sure that y'all can see it. Okay. Just gonna set up my environment while we wait. Hi Thomas. Can you hear me all right? Is the video good? Please let me know. And we'll start the screencast real quick. One moment. Yeah, all right. Thanks, Thomas. Thanks for helping me out here. All right. I see people joining. That's really nice. We did a 23-hour announcement prior to this stream, and we're testing out if this works for you. Hey, Justin, my man, thanks for joining and helping us out every time. It's a real pleasure to have you. Okay, so we're right on time. Thanks everyone for joining. We're continuing to experiment with our format with announcements and times. And today we had 23 hours worth of time prior to the start of the stream. We'll see how it goes. So my name is Morgan. I represent Decentology and Flow for the Mercury Hackathon. It's really nice to have you here, have you participate in the hackathon and see what kind of cool decentralized apps you're going to build. This is a skill set that's extremely important right now, and going into the future it's going to be even more and more important. And hackathons are just a really great platform to get started, kind of act as a forcing function to just push you forward, learn new things, and try and apply them, and maybe build a little bit of a network. Because who knows, like if we see you guys doing something really cool, there's tons of people looking at everyone's performance, how the teams are building things. You know, I'm sure we're going to have some nice networking opportunities towards the end of the hackathon. All right, so let's see who's online. Hi Latif, hi Saputra. Mayrab is asking, where's Jacob? Jacob is occupied today, and unfortunately he won't be joining us for the stream. At least that's the latest that I had. But he'll be with us later this week. And hi Shayad. And for today, it's just going to be me, and we're going to continue working on the Mercury Hopium repository that we've had some luck with recently with deploying an NFT contract. So having said all of that, for everyone on YouTube and on Slack, I guess we can start coding. All right, let me switch into the screencast. Awesome, Ex Machina. I see you have office hours tomorrow. Really looking forward to seeing your progress. It's important that every single week you guys are building on what you've learned, and you're making progress. And if you guys are stuck, we're here to help, and this is one of the ways that we're trying to help. So let's explore here. We have our VS Code editor, and we have our trusty terminal. Let me know if the font sizes are good for everyone. Let's just start this app. Okay, well, it's reloading. We'll focus back on the editor. Okay, so now we have, I see no comments with regards to the font size, so I assume it's all good. So now we have this sort of a tiny widget that displays the flow token balances and whether each one of these accounts has an NFT collection. This is something where we left off last time. And what collection is that, you might be asking? Well, we created this awesome Nifty contract with a resource type, NFT. Now this name can be anything, just because it's an NFT, and we call it an NFT. Maybe a lack of creativity was the reason for it. This is not a standard, and you don't have to name yours NFT. And this NFT has a couple of fields. One's the identifier, an unsigned integer, and the other one's a name. Okay, so this is going to store some kind of a string, and we can mint them sequentially, and assign each one with a unique identifier. So each one is going to be different, and the difference is going to be determined using this ID. Thanks, Justin, for confirming that. So the difference is the numeric identifier. Now, we want to ensure the uniqueness, and the way to ensure that is by having this extra resource called Minter. It is going to maintain a counter for the total supply of all of these NFTs that have been created. Okay. Right. Finally, we have this create collection function that creates a collection and returns the resource. And the collection resource is a dictionary of NFTs. So the keys are the ID of the NFT, and the value is the NFT resource itself. This @ symbol, I wonder if anyone in the chat can help me out with this one. Just making sure you guys are keeping track. What does it mean if I have an @ in front of a type? For example, let chat bool because this is part of the evolution of Cadence, and the difference between Cadence and Solidity. We have resources, and resources are specific types that you can only exist in one place. You cannot make copies, and you can only move them. All right. Right. So Mayorab responded, it means a resource, and that's exactly what it is. This denotes a resource, and the syntactic sugar here is important so that developers, anyone reading the source code, is well aware that when I see this, I have to use the create keyword, I have to use the movement operator, and I have to use the destroy keyword when interacting with it. Okay, so we have this collection, it maintains a dictionary. Upon destruction, it's going to destroy the Nifty's dictionary. So that's all good. And then there's these three functions where we can withdraw a specific Nifty with an ID, and we can deposit a Nifty, which is a resource, and add it to our Nifty's dictionary. And we also can get the IDs of a given collection, of what's inside of that collection, that is. Okay. So let us try something out here. Did I change anything? Oh yeah. Save that. Okay, so we have this contract, and we have it rendered out in this kind of rudimentary style. And we have these accounts. 3 of them we don't control. Hi, BZ. How are you? Thanks for coming to the stream. So we have these 3 accounts, and we don't control them, so we can't really create a collection. And if you guys remember from yesterday, when I wanted to create a collection, I logged in with my Blockdo wallet and clicked on create collection, and it went through. Let's try and create a collection for, I think this is Mehrab's account. So I'm going to try and approve this and see what we get. All right. So we have, if anyone can see this error, we have a cadence, a runtime execution failed. All right. And awesome Nifty Collection failed to save object. Okay. Let's try and save this with Jacob's account. Let's approve that. Got to wait a little bit. We're interacting with the, all right, already stores an object. So this error is not too descriptive. Like in essence, it should have told us that, or rather, the account that we're signing for, we don't have the access to. But I believe that transaction doesn't really on create collection. So we send this transaction. All right. So it's actually, we're not even setting a parameter for the account. So we're creating the collection for the account itself. Okay. So we shouldn't have a button there. So let's fix this user interface a little bit so that it's more easier to read. Okay. So we have account. Let's minimize these so that's easier to navigate. Okay, so we have this button here. It should only exist for the primary user. In that sense, primary user is right here. Okay, so let's add another div. And let's take this button here. Move it over. And we also have to move the function and the state variable. Okay. So has collection is something that we attain by checking for collection. And let's see here. So organizing these things can become a little difficult. So on create collection, that's gonna give us that. On send is still there. Okay. So does this take in any? Okay. So how about we create an abstraction, because what we're interested in, so on create collection, we moved it to this page right here so that it's accessible to this button. But it has collection is something that we're gonna need both in individual accounts as well as because we're setting has collection right here. Okay. Let's see here. Let's try and think of something. How about we You know what? We'll just duplicate this for now, since it's not our main goal to ensure a good structure just for the moment. Okay, so check collection is going to do that, and this sucker right here is also going to live here. Okay, so let's see if this runs still. As collection is working. We don't have a button there just yet. Check collection is not run, and that's because we need to run this on the first render, on mount rather. So use effect, okay, and we're gonna do check collection. Expected address for type address, and the problem here is okay, so since we're checking for the account itself, the list of arguments is going to be empty, and we don't need this address right here. One moment. Oh, we still need to pass in the address. So the address is user. Let's try and log and see what the structure is for user. That comes from FCO. So let's see. User, we have the ADDR abbreviation, classic. Okay. Boom. So let's just send that. Okay. So right now that works, and just to fool the system, let's fake it. Okay, so we have this create collection button. It appears. All right, so at this point, we have refactored this a little bit. So this just checks things, and for legibility, let's, I don't know, maybe turn this into an ordered list or an unordered list. Okay, and first item, oops. First item is going to be the address, and we can make that strong. Then the second item is going to be the balance. Okay. And in fact, I feel like it makes sense if, depending on the loading state, so if balance is not equal to null and has collection, you know what, we're complicating. Let's simplify this. All right, so we're going to check the balance. Balance is going to be this. And what else? Collection status has collection. This is going to be yes or no. See how that looks? Okay, so we got balance, and then we have house collection. Let's specify that this is a flow balance. So balance flow. Okay. Let's get rid of that console cruff. We have one collection, two collections. Okay. So that seems decent enough. Now, in our commands section right here, let's create another command Let's see if we turn these into paragraphs. Is that gonna make them look better? I sure hope. Okay, so there's some separation there. And maybe we add a little bit of padding here. Doesn't hurt. 64 pixels. And what? 16 is going to be plenty. Okay. Get rid of that hello thing. It's been bugging me a little bit. All right. So we got these accounts. We got some commands. So we're going to add another command, and that command is going to mint an NFT. All right. This is a big part of what everyone is going to be building for the hackathon. So let's borrow here. So now this is going to be text input, and it's going to be the Nifty name. And let's set this to Nifty name. What else? Receiver address. You know what? We might as well keep the same. And then on mint. And let's just call this mint Nifty. Okay, let's see how that looks. Nifty is not defined. Well, that is expected. Cool. So const Nifty name set Nifty name, and we're going to start with an empty string. On mint is not defined. Okay. Let's define it, shall we? Const on mint is an asynchronous function, and we're just going to prevent the default. Okay, now it should render. Mint Nifty. Let's test it out. Test, and we have an address there. So at this point, we're gonna console log what we're gonna log. We're gonna log the Nifty name, and we're gonna log the receiver address. With these two values, we can create a transaction. So mint Nifty, we have a string, and we have an account address. Okay, so now we have this on send transaction. We can inspire ourselves with that and replicate it. So on send, on mint. Okay, well, we start with, one moment, we start with a try catch block. Now if a transaction fails, it spits out something, and if we don't deal with it, then a user's going to have a pretty bad experience. So we're just going to console error this error right here. Got to stay hydrated. That's key, right? And we start with, the standard stuff. So transaction ID. We're going to wait for FCL send. Okay, we're going to build it from scratch. FCL send takes in a sequence of objects. One of them is FCL transaction. Okay, so how do we mint? Well, first, mint lives, the definitions of that function exist in the Nifty, in the awesome Nifty contract. So we got to import that. Okay, import awesome Nifty from. Now, where does it live? Okay, well, we can take a look at flow view source, and awesome Nifty lives with this account address. Okay, so we go ahead and take that and import. Next, we open up the transaction body, and we have a prepare statement. We're going to be dealing with account storage, and as such, we need to have an authorization. In the prepare section, or the prepare phase of a transaction handles all the authorized account access. So in this little blob right here, this is authorized. Okay, so this is where we can add, access, remove, deal with account storage directly. And we're going to sign it, this transaction, with a single auth account. Okay, and what we're going to do here, well, two things, I guess. Since we are the account that owns the minter, okay, it's in our storage. Let's take a look. We stored it at storage awesome nifty minter. Okay, well, we have to load it then to be able to perform actions on it. So let minter is going to be account dot load, and then let's take a look at the documentation. Let's see here, accounts, storage, and save load. All right, so this load function here is what we're interested in. We want to load an object from account storage. Specifically, we want to load the minter object. It takes in one argument, and we have to define a type. Returns the optional of that type. Okay, so we're going to load the minter, and we're going to load it from this address. Okay, and since we're sure that we have the minter, we're just going to exclamation mark it or force unwrap it. Okay, now we have to define the type, and the type is going to be awesome nifty. So remember, we're no longer dealing with the contract within itself. So that means we have to namespace any function, any type with the contract name, right? So in this case, the loaded resource is going to be Nft minter. Okay, and let's see here. This is going to be a resource. So, okay. So we have this minter right here. And what does a minter do? Well, it mints a given string. Okay. So now let's see. We have a transaction, right? And transactions do accept arguments, as we can see right here. So we're going to have two arguments. First one is going to be the name. It's going to be this the string, and then we're going to have a receiver, which is going to be the address of the receiver account of what we're minting. Okay, so now have access to the minter, and we're going to minter.mint the name that's provided. Okay, so this is going to create an NFT. It's going to reference the total supply for the ID. It's going to increment the total supply, and it's going to return that NFT. Okay, so nifty, we store it here. Okay, so now minter is done. Okay, so we can account.save and put it back where we found it. Okay, so account.save, and we're just going to move minter right here, and we're going to put it back to storage. Awesome nifty minter. Okay, so now we're done with the minter, and we have the nifty. Now we need to access the receiver's collection, okay, and store it there. So let's try this. Let receiver, let's rename this receiver address. So receiver is going to be get account, and we can take a look at get account in the documentation. So get account takes in an unnamed address, and we're going to use that right here to get the account. That's the receiver. Okay, we feed it with that. And at that point, we can take a look at what's the interface. Well, the interface is public account. Where is public account defined? At the top. And what does it have? Well, it has this get capability. Okay. So this capability is going to allow us to interface with our collection and deposit this newly minted Nifty. So we're going to call get capability. Okay. And the capability takes in an argument that's path. The path is this public thing right here, public/awesome Nifty collection. Okay. Boom, boom. So when we're getting this, we have to let the system know what kind of type this capability is, or in this case, it's going to be a reference. And this reference is going to be a receiver, but again, we're interfacing in a transaction that's not inside of a contract, so we have to namespace everything. So like we linked it in the account as a receiver right here, we're going to get the capability back as a awesome Nifty receiver. You know, so it's a little name spacing right there. And in fact, we can go ahead and move that to borrow. Okay, so now we have this receiver, and we're going to borrow a reference to it. And if that doesn't work, we're going to panic because we can't deposit our Nifty here. So we're going to let the system know couldn't borrow the receiver's collection. Okay, so that's bad. If that happens, we shut everything down, revert all the changes that occurred during the transaction, and that'll be that. Okay, so now we have the receiver collection, and let's use the deposit function here, deposit, and it's taking one argument, which is the Nifty, and we move our Nifty into this deposit function right here. And that should do it. Of course, we'll know for sure once we try and execute this. We just got to feed it a couple of arguments. Okay. So fcl.args, and we're doing fcl.arg. We're sending the name. Okay. So the name comes from Nifty name. Okay. So that's Nifty name, and it's flow types string. Then we're sending the receiver address, and that's already stored. It's a flow types address. All right. So now we have our arguments. Then remember the three steps of composing a transaction. We have a payer, a proposer, and authorizations. In this case, it's all one account. So we just have to let FCL know that the payer is fcl.authz. So this is referencing us. Okay. fcl.proposer is fcl.authz. And FCL authorizations is an array of us. Okay, single authorization. Then we do FCL limit to the max number of gas fees. Okay, and once we're done, we wait until we receive a response, and the response is something that the access node sends back, and we just decode that into a JavaScript interface. Okay, so at that point, we can go ahead and look for the result, which we fetch by taking the transaction ID that we stored as a response. And we're going to look for sealed. Okay. And let's log the result. This is going to be fun. This is a big transaction, and we wrote it all down without testing it. And now we're going to test it. Okay, reload. So we're going to mint a Nifty called, let's call it hello. And we're going to send it to us, right? That's us. Okay. Mint Nifty. This is an authorized transaction, so we need to sign it. Let's go ahead and approve that. And let's see, fingers crossed, promise pending. Okay. I guess I'm missing an await here somewhere. Oh, so two things happened that I wasn't expecting. Unexpectedly found nil. So the minter is not with us, I guess. Let's check which account is it stored with. Is it this one? Yep, it's this account, so that should be fine. The parts about live coding is you never get exhausted by all the things that can go wrong. All right, so let's look at this promise here, right? First, so 194 was where this promise happened, and result. All right, so we have to wait for that. That's all good. In fact, let's maximize our screen real estate. So we're loading this awesome Nifty minter, and we're loading it from storage awesome Nifty minter. Okay, I will inspect this prom, so just one moment if you were to bear with me. I'm inspecting another contract, just one moment. Okay, let's see here. Okay, so I wonder if we stored the NFT minter right now. Let's take this and inspect the source code. The minter is there. We're storing. Okay. Well, I guess I'm going to edit this and save the changes. Approve this bad boy. Okay, so that's saved. Let's reload Hopium and hope it works. Okay, so now I have to have a minter, right? Let's mint an NFT that says minter. Approve. And what do we get? We have, again, a forcible unwrapping. So that means we don't have the minter. Account, create minter to storage. Am I using the wrong path? I'm using the right path though. Interesting. I wonder if anyone is aware of where I got this wrong. This is bothering me a little bit. So we have account, which is the authorized account, and it's loading this awesome nifty minter. Okay, so that's all good. From storage, that's all good too. And awesome nifty minter storage. Unfortunately, we can't really take a look at it. Or maybe we can. What if we, you know what if we create a link? Yeah, let's try and create a link. So like we have this self.account.link for our collection. Let's just have one for this minter right here. So it's going to have all the functionality that our regular minter does. But that doesn't seem right. Okay, because then anyone publicly can create these. Maybe that's not a big problem. All right, let's create a public awesome nifty minter path. And the target is going to be awesome nifty. But if what if I rename this? I'm going to rename this to uppercase A. And comment this out. Because this has to work. I'm going to replace this, that, and the other. And redeploy this contract. Save changes. How's everyone doing in the chat? Y'all having fun? Curious to know how you're doing. Okay, we deployed it. Let's reload and test again. Am I sending it the right stuff? I'm sending it test and the account address, and the minter is loading based on auth account. I'm authorizing it as me, and all right, let's test it out. Yep, Latif is doing all right. That's great to hear. Ah, we're getting the same error. Let's see if we can load anything at all. Because at this point I'm rather suspicious. Okay, so we comment this out. We comment this out too, and let's just do collection. Collection. We're gonna do account.load, and we know that we have a collection because it says so right here and right here. So we should be able to load it. Okay, so that collection is of type awesomeminter.collection, and it's located in storage / awesome nifty collection. Okay, but then we put it back. Okay, and we're going to save collection back to its original location in the storage awesome nifty collection. Okay, so this should work because we have a collection and it's outlined in the account list. So let's do an accounts. It's not going to send. It's not going to create a nifty, but it's going to load and save something. Okay, failed to send transaction to collection node 3. Failed to send, okay. Failed to parse. What seems to be the problem here? From storage? Oh, of course, storage. We're missing storage. My bad. Let's reload. Reload again for safety. Click it again. The goal is to load something and put it back into storage, and if we can do that, and maybe we can make some progress. Let's see here. Okay. We got 3 events. Tokens withdrawn, tokens deposited. So we were able to load stuff from our collection. We were able to put it back. All right. Let's see if we can delete it. So we load it from our collection. We load our collection from the account. Okay. I'm going to be a little destructive here, and we're going to destroy this collection, and then the state will change, and we're just going to sort of iterate from there. So now this has collection, yes. Let's mint the Nifty. Click on approve. And by the time it goes through, okay. All right. So I think I know what the problem is. Even though this is, oh man, this is really good. Guys, I'm signed in as this account. I should have known. All right. So this account is just a regular account. I created a collection for it, but that's about it. This account has the minter associated. Okay. So we have to sign out and sign back in. But right now I'm just going to create a collection because I deleted one, and we're sort of going to revert back. This just feels so good. Solving a problem is always great. And it was just a really silly problem of me being logged in with the non-minter account. Okay, so we still have a collection. That's good. Let's comment this part out, and let's uncomment this. And we should be good. Let's sign out and sign back in with a different account, Morgan at Decentology.com. Okay. Let's have a little privacy here for a moment. Shouldn't take too long. Okay. Logging back in. We're going to use this. Okay. Sweet. So let's call this Sweet Nifty. Mint Nifty. Approve it. And are we going to get the success message right here? We should. Man. But it's different. All right. We're loading the collection. Why are we loading a collection? Right. Sorry. Didn't comment everything out. You guys should have caught this. All right, let's do this again with Sweet. So it reverts back anytime there's an error. So we don't have to worry about losing stuff if something wrong happens with the transaction. But now this is it. I think this is it. It isn't. Found nil when force unwrapping. God, this is one of those days. Let's make sure that we're under this username. So right here, where do we do that? Under app.jsx. So let's see what user is when we log in. Okay, so we have this 5831A. Okay, That's the account. That is the account. So we're logged in with the correct account. I did change these a little bit. I wonder if that messed it up. Try again. Again. Okay, let's approve the transaction. What are we gonna get? Are we gonna get a transaction ID? Holy moly. So what happened was the contract with all my updates and everything had the lowercase version. So even though I made these changes right here, it didn't actually submit them properly. Okay, so we have our minter, and nothing's really changed there. Do you use environment variables? Mayrab is asking. I use environment variables when I'm not live coding from scratch, but this is a little different environment. So I just want to give you guys a sense of sort of the real world experience of getting and building this stuff live. So it's not all glamorous. All right, so now we have minted something, and some things should be in our collection. We really want to print what's inside of that collection, okay? So we have this check collection thing, but let us create another item right here. So we're going to create another script, which is fetch collection. This is all the same. We're getting the collection reference, and we're going to return an array of unsigned integers, an optional rather, and we're just going to do get IDs. Okay, I believe that's the name of the function. Get IDs, yep. And okay, so IDs is what we're getting, and set IDs. I think that should work. Let's create another state variable. With null to begin with. And let's call the fetch collection. Okay. And to begin with, we're just going to console log our IDs real quick. IDs is not defined. Interesting. Oh, because it's IDs. And what's wrong? Cadence runtime error, URL scheme, blah, 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 blah. Get IDs, unknown member. Okay. Okay. So we have a few instances of empty arrays and one instance that with an array that has 0 in it. Conveniently, that 0 is the first ID. Okay, so let's call this first and mint that. Approve. And what we're looking for is we're looking for that array to update once we receive the go ahead. Okay, so status 4, that means we're good. Okay, so now right here, we're going to check if IDs have been returned, and if they have, we're going to map each ID index, or rather we don't need an index, we can just use the ID. And we're gonna do, what are we going to do? All right, an ordered list. No, let's keep it unordered. So an ordered list, and this is just gonna map list items, and each list item is going to be the ID itself. Okay, see if that works. Cool. Clear the console right here. We're missing some React type stuff, so let's fix that. Okay, so now this account has minted some stuff, and it's got 2 NFTs, but we're only getting the IDs there, right? We want to get some more. Let's see, how do we extract more? We get the Nifty keys, and is that it? Yeah, that is it. That's very unfortunate. Let's do pub fun get name, and then ID is going to be an unsigned int 64. It's going to return a string for a specific Nifty, self.nifties ID.name. I wonder, so each Nifty has an NFT, and it's got a name. Oh, okay, that should do it. Okay, so let's see if we can redeploy this. Save changes. Let's authorize this. Sealed, that means we're good. So now we're gonna update this fetch collection thing, and we're gonna return an array of, let's do an array of arrays. Hope that works. Or maybe of structures or objects. So ID is going to be uint 64, and then name is going to be string. All right, so we have this get IDs thing. Now, let's take a look at the values and types, and let's take a look at arrays. So what do we have? Array indexing, length. Okay. So we want to iterate, but we don't have like a for each equivalent here. So we should probably get into control flow and look at looping. For in, okay, well that's nice. So we can do for element in array to loop over our IDs. So let's see here. Inside of here, we'll do if collection ref is not nil, then we're gonna do for ID in, or right here. Okay, so with that ID, we can go ahead and look at what are we doing? We're doing a result, and result is this type, and it starts as an empty array, and we append to it, right? So let's look at the types again. Let's look at arrays and array functions, indexing, length, concat, contains, append. Okay, so we do append, and we're appending ID equals ID, and name equals get collection get, and then this thing was get name. And we have an argument ID. Okay, so get collection, get name, we append it to result and return it. Otherwise, we're returning nil. Let's see if that does anything. Boom, we're getting some errors right here. What does it say? Unexpected comma in dictionary type. Ouch. Sorry. So we're out of time for today. I'm really sorry we're leaving it off at a point where we're declaring this type, and we have to declare this type in the contract itself. Maybe I can fix that real quick. I don't know. Pub struct Nft struct, and what it has is a name and an ID, and it gets initialized. So it's kind of like a representation. Okay. And you know what? I'll come up with a better structure for next time. We're gonna cut it exactly on the hour. I do appreciate everyone joining me today. We got to explore the minting process, but more so we got to explore the debugging process, which I didn't plan for, but you play with the cards that you were dealt. So yeah, we're gonna look at minting further next time. We're gonna look at depositing and withdrawing Nifties from one account to another, and we're sort of slowly building towards a concept of a marketplace. All right. So from me, Morgan, and the rest of the team at Decentology, I want to say thank you. And with regards to Hacktoberfest, the BZ's asking, that's going to be on a YouTube stream with Decentology, and we're going to tweet out some links right after this. All right, everyone. Thank you. Thanks for watching and being with me. And for now, goodbye.